Hi guys, I'm Gunnar and welcome to Part 5b. Like last time, I have added timeline chapters in the description below, so let's just continue where we left off. I have mentioned that this is going to be the final update of the laser, but this is still a DIY build. So my plan is to try and separate the different kinds of things within the machine a little. So I want a place for the electronics with plugs and connectors on a backplate or something, everything from sensors to stepper motors and whatnot, as I've been collecting stuff for a while now. Also a section for the water cooling, if that at some point will need an upgrade or water change, with some quick connector plugs and a bottom drainage system if it should spring a leak. Also just a section for general storage, like some attachments, my modular grid pieces, notes for cutting speeds and general use, as well as a section for air assist and maybe for an optional PC. Just to be able to take that complete module or section out for easier upgrades and general maintenance, but also keeping it organized and easier to manage during this build update. As for the controller, I've mentioned before that I run the laser as a CNC machine with this Pokey's 56U board and Mach 3 software. Which is fine, I can do vector engraving and vector cutting, but when I look at what people do with their lasers with raster engravings, I mean, wow, that's pretty nice. So my plan is to have the option to do that, to buy a fixed laser engraving board such as a DSP or the Ruinad or some other controller able to do raster engravings. But I'm not sure as to which one to choose. From the brief googling that I've done, people talk rather highly of the DSP controller, which seems to be quite nice. But what do you guys think I should go for? And by that, I'm also talking about the supported softwares and the speeds it can achieve. And then there's the lid. I mean, in the beginning it didn't do this much binding, and that might have been a little exaggerated, but you get the point. It might have been because we moved to a new workshop last year, so by moving the machine maybe it changed a little. Nonetheless, the machine works fine. From the get-go, I did need to add a second handle because it is quite big and flexible for its size and lack of support structure. So of course I want to add more structure. And secondly, I don't want the profiles touching each other in the front, as that is the whole issue. Instead, I would have the profiles more inward and the counterpart to be a 20x40 profile, so I would close on top of the profile like so. But nothing is decided just yet. And not to be picky about it, but I really don't like this gap these hinges are doing at the moment. Also because I want the lid to be 100% aligned in the front part as well, without changing my profile dimensions to some weird numbers. Getting another kind of hinge would definitely do the trick, but I'll figure it out when I'm designing it, because there are also other ways of opening a door. So I might go with something completely different, I think. Currently, I have these NEMA 23 stepper motors installed in the machine, and they have 1.8 degrees per step. That gives me the standard 200 steps per revolution. And by running that directly to the belt with my 15 teeth gears, gives me roughly around 75 millimeters per revolution, which is 0.375 millimeters per step, which isn't really that good, so I compensate by microstepping at 128 steps per full step, giving me a total of 25,600 steps per revolution, and a final resolution of 0.0029 millimeters per step, which is, well, enough for what I need. Also taking into account that my controller can step at a maximum of 125 kilohertz, giving me a maximum speed of 366 millimeters per second or 21,960 millimeters per minute for the CNC folks out there. However, I did from the start buy some 30 teeth gears as I wanted some gear reduction, but I simply couldn't design anything compact enough for the space I had, so I left them out. I was in a hurry. This is definitely something I want in the update, as I would like more gear reduction instead of micro-stepping that high, as running a stepper with that amount of steps isn't that reliable, and when resetting or enabling the axis, they tend to force the stepper motors to a full step, which then would actually move the 0 point of the machine a tiny bit, and sometimes enough that it is noticeable. I believe with the gear reduction from 15 teeth to 30 teeth gear and reducing the microsteps to 32 microsteps per full step would give me less resolution, but still plenty, more torque, and double the speed. Let's calculate a little. 30 teeth divided by 15 teeth gives me a ratio of 2. The 200 steps per revolution that the stepper motor has times the gear reduction ratio of 2 gives me 400 steps needed for 1 revolution on the output. And here's how it's going to work. The stepper motor is going to run these 15 teeth gear to a 30 teeth gear. And on the 30 teeth gear is going to be another 15 teeth gear. So this is going to run the laser head back and forth. 75 millimeters of travel divided by the 400 steps would now give me a 0.1875 millimeters of travel per full step. Microstepping that down to 32 steps per full step gives me a total of 6,400 steps times the gear reduction of 2, equaling to 12,800 steps per revolution on the output shaft. 75 millimeters of travel per revolution divided by the 12,800 steps gives me a resolution of 0.0058 millimeters per step, or 0.000228 inches per step, which is a little less resolution than before, but again, plenty, I believe. That in turns gives me back some speed, which should be around 732 millimeters per second, or in CNC terms, equivalent of 43,900 millimeters, or 1,728 inches per minute, which is calculated like so. The maximum speed that my controller can pulse is 125 kilohertz divided by the 12,800 steps per revolution gives me 9.76 revolutions per second times the 75 millimeters of travel per revolution, equaling to 732 millimeters per second, or times 60, equaling to 43,900 millimeters per minute. Okay, I think my math is correct here, but you get the point. The gearing will increase my resolution without me needing to microstep so high. There are also steppers you can get with 0.9 degree positioning, doubling the full steps up to 400 steps per revolution, which I might consider, but it's not a priority, but optional if needed. I do, however, plan on getting some form of closed-loop systems, or hybrid stepper motors as you call them, that have encoders built in, as I would really like to test it, especially with the laser. Oh, and I know that I'm adding some backlash to the system by adding the gear reduction, and I'll have to minimize that as much as possible mechanically, and then maybe compensate for it in the software. But what do you think? The whole reason for buying this metal sheet bender is actually because I want the machine to have a little more of an industrial and clean look to it instead of my current laminated MDF covering, which is okay, but okay is not really what I'm aiming for here, as I would like it to look a little better, with looks concern, but also regarding the safety of aluminum not being flammable, and MDF is. I want to make the paneling out of these 1mm thick aluminum sheets, and I want them to be modular so I can easily remove them from the machine with some form of a locking mechanism. There are many ways on how to do this, and I have some rough ideas, but I'll have to update you guys later in the design as some testing might be required. However, there are some restrictions. This metal sheet bender can only bend sheets up to 620 millimeters wide, but I think it should be fine as I want the panels in sections anyway. If you guys have seen something fancy or have a good idea on how to panel something with the tools I got, please let me know. As for the air assist, I've got this fish pump running all the time, which is hooked up to the nozzle, just to keep the nozzle at a constant positive pressure in order to protect the focus lens from the smoke and dust. And combined with this T-fitting, I also have a dual airbrush compressor hooked up and turn that on when cutting, which pretty much just delivers whatever it can to the nozzle, so no pressure regulation at all, because the regulator that came with the airbrush compressor varies too much when the pressure in the tank changes, so not really usable. I'm not going to be focusing on the air assist in this update, as it is kind of a side project, but I would like to try and control the pressure coming out of the nozzle more consistently, as the air coming out of the nozzle from the airbrush compressor comes out in bursts, which you can clearly see on some materials as the surface finish isn't that smooth. The air assist is awesome when cutting, for example, MDF or plywood, as it keeps the burn marks to a bare minimum, which you can see here with a typical cut without air assist and a cut with the air assist turned on. Of course, this is possible for me with this type of nozzle right above the material. In the future, I might want to have something more powerful, as having a higher air pressure in the nozzle can really make a difference cutting thicker materials, and the increase in speed by which you can cut, saving time as well. Now, the reason for this update is simply because I'm not really that happy or satisfied with how I made the machine in the first place. I mean, it's a longer build, and somewhere along the way I just got to the point where I wanted it done. And of course the excitement of if the machine would actually work.
Ready? Yeah.
Holy shit. That's awesome.
Made a spot.
I made a spot.
And when it did, I just wanted to create stuff with it. Well, this is kind of a way for me to test myself, as when I semi-finished the CNC machine, I could come up with all kinds of ideas how to improve it. But I was so busy using it that instead of improving it later on, I started the laser cutter build, which was a new and exciting project. And it turned out great considering I was pretty much just winging it as the build progressed. That's also one of the reasons I don't have a bill of materials for you guys, but also I wouldn't really recommend anyone building this machine. It's more of a you built it, now live with it kind of thing, if you know what I mean. Anyhow, I kind of made the same mistakes as with the CNC machine, as in the end, I rushed it. And by the second time I improved the laser cutting ideas were piling up. So in the end of that, I rushed it as well. What I'm trying to say here is that I don't want to rush this update, as I really want it to be the final one. A good test for me to behave. And now I also have some extra tools to help me along the way. Let's see. The more I plan ahead and design, the faster and better the update will be. Especially since I'll be needing to order a lot of stuff in good time, as I don't want to wait. And I know that as soon as I disassemble the machine, I will start to get that urge to laser cut something again. And a last second insert here regarding safety that I mentioned in part 4, where I showed the big hole that had burned through my table. Well, Thunderbelch suggested that I could add a hard to miss indicator or warning light to the machine whenever the laser is active. And that's a pretty good suggestion, so I'm definitely going to add that in some hard to miss kind of way. Thanks, Thunderbelch. I also want to add a activate button to the machine that enables the laser in the first place, as that is a feature I'm quite fond of having, as well as a switch for the lid and some form of feedback that checks for the water flow, so it disables the laser if no water is flowing. I think that was it. I'm not going to talk about the comments from the first video just yet. I'll wait and see for the comments from this video as well. And when at some point a lot of decisions and a lot of Googling and reading has been done, I think I will end this BuildLog series with a conclusion videos to let you guys know what I'm going for and why. Please be patient, as this might take a while, but in the meantime I will be making other videos just for fun. So I guess there's only one thing to say now. Thank you for watching. Most importantly, thank you for subscribing, and I really appreciate the comments. See you in the next one. See you in the next one. See you in the next one. And what? See you in the... No, that's not good enough.